Welcome to Never Don't Ask with me, John Martin. Cross between engineering, science, maths, history, and griping about things on YouTube. And this is going to be pretty much a griping about things on YouTube episode. I haven't quite officially launched the channel yet. And I thought what I really need is a bit more money for equipment. And so I was really happy when I saw a video posted by Simon Dan on his channel, link below to that, which featured a video by a builder and flat earth supporter, Calvin Stroud. Video also linked in the description. And he gave an explanation using his knowledge as a builder of why the earth has to be flat. And so I'm going to talk a little bit about the video. Then he offered £10,000 to prove him wrong. So I'm going to then do a bit of working out up there somewhere, and then I'm going to sum it up and ask him for the money. Or maybe I'm not. It depends. He could be completely right. Now, what this video starts off with is him talking about a building method, says 3, 4, 5. And that's 3 bricks up, 4 bricks along, 5 bricks in the diagonal. And he's saying that's a way of working out a right angle, which it is. It's Pythagorean. It's a Pythagoras theorem. The square on the hypotenuse of a right angle triangle is equal to the sum of the square of the 2 adjacent sides. What that means is that if you take the square of the long side, the hypotenuse, and let's say, here's for example 5, so it's 25 squared is 25, it's equal to the sum of the squares on the 2 other sides. 3, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Let's say, and this is good either working out if a triangle is a right angled triangle, if you know all the angles, or if you know that this is a right angled triangle, you can work out the missing side. It is something that we do a lot of when I'm teaching maths, and when you're doing A-level maths. Well, previously, when you had the non-calculator paper, you knew if there was a 3 and a 4 turning up near circles or triangles, there'll be a 5 turning up. There are many, many of these Pythagorean triples. 5, 12, 13 is another one that pops up a lot. 5 squared is 25, 12 squared is 144, add them both together, 169, which is 13 squared. Now, what's interesting about this is that Pythagoras, if he existed at all, it might be a school that was a Pythagorean school, or it's just a certain person. There may be a video coming about him eventually. Really interesting guy or guys. But this was the first school that taught that the earth was a sphere, or one of the first schools. It was certainly very central to popularizing the idea that the earth was a sphere. So good choice there, Calvin. The school was based in Sicily, which was a Greek colony at the time. Now, Calvin is going to talk about some instruments he used. I just want to explain briefly what they are, to how he made sure these things are 90 degrees. And the first thing he talks about is a plumb line. And you can check out the video for how he actually works this out. And I will explain his working out a bit when I'm doing mine. I just want to explain the instruments first. The first one is a plumb line, and as he explained it quite well, it's a weight on a piece of string. It's originally a lead weight, plumbum, Latin for lead, plumb line, get that, and it's a plumb bob at the end. Now this points straight downwards, always points straight downwards, because like everything, it wants to have the least amount of gravitational potential energy, and that is at the point nearest to the gravitational center of the Earth in the Earth's gravitational field. That's why it points down. He's also talking about how we get a level thing, and his tools are laser levels, water levels, spirit levels. So spirit level, water levels, you've probably all seen them before. They're a block, normally plastic or wood or something, with water inside, not totally filled up, or spirit inside if it's a spirit level. There's normally a little bubble of air, and that little bubble of air, and there's a window at the top, and that bubble of air sits between 2 markings if things are level. And that's because water like everything else, wants to be at the lowest point of gravitational potential energy. So it goes to the bottom, and that little bit of water, that little bit of air goes to where it's the top bit, say up there. If the thing was slanted, then all the water would come down to the bottom, being heavier, and the air would go up to the top. So if it's in the middle, it's level, or spirit, or whatever we're doing. Laser levels. Lasers invented in the 1960s for the quantum mechanics, and using that and electronics comes out with a leveling system. I'll talk more about this in the end, about how accurate they are. So what we're now going to do is go and look at, does his working out work? Now I want to say, for this next part of the video, the bits that's going to be up there, that I am going to be agnostic about whether the Earth is a sphere or not. I will try and have a completely blank mind. I will accept he could be right. I can accept Simon Dan and Pythagoras could be right. What do I know? Well, I've got a degree in astrophysics. But what will I know at this point? I do not know. I'm just going to let the maths deal with it and see if Calvin's explanation of what is happening holds up.
So the first move is I am going to throw some graph paper on this. I have two reasons for this. The first is we're doing mathsy and sciencey stuff, so graph paper looks cool, especially if it's branded. The second is that we can use it to more accurately compare sizes, especially as I'm going to have to zoom in to show things clearer. So next off, I'm going to draw a circle. This will represent the Earth. If we are meant to believe Simon Dan or Pythagoras, remember, this section of the video, I remain a geotopological nihilist. I will have no views on whether the Earth is spheroid or flat. Needless to say, if you believe the globe Earth, this should be a 3D sphere. Then the drawing gets really complicated. However, Calvin used 2D in his demonstration, so we should be okay. Now we're going to zoom in and find that firstly I forgot to fade the graph paper a bit, but there are two walls drawn on here. The first is pretty obvious, it's a slant from page vertical. The other is rising page vertical from the very top of the circle. I want people to notice that the slanted wall crosses the edge, the circumference, of the circle 5 small squares away horizontally from the vertical wall. This will also become more clear. Both walls are the same height, the same length, and the same distance from the circumference. Now, I don't have a plumb line. Also, quick note, plumb being, as I said earlier, related to lead. Lead to be used for pipes, because it's easy to work and bend, hence we got the word plumber. That's a bonus construction industry fact from me. Anyway, no plumb line. So how do I make sure this is a 90-degree angle? Easy, we use maths. No calculations needed, we use a mathematical theorem. Note that the M on the end, the theorem, is proven mathematically. It's something mathematicians are allowed to do. Anyway, according to the theorem, the radius of any circle, that is a line extended from the centre to the edge, intersects with the circumference at 90 degrees. So both of these walls are actually drawn from the centre out to the edge and then extended. I hope that myself and Calvin can agree that these are both at 90 degrees to the circumference representing the surface of the Earth. Now, I also don't have a spirit level I can use on the screen, but I do have the rotate command. So I just rotated the slanted wall by 90 degrees. So now we have 2 walls and a roof and 3 90-degree angles. And Calvin is right. This last angle does not look like another right angle. The house looks suspiciously wonky. A quick bit of fun with a protractor showed me this was 80 degrees. Not quite Calvin's number, but close. However, why wasn't it Calvin's number? Maybe I drew the wrong size. However, Calvin says that the size and scale does not matter, which is good, because a wall this size on the Simon Dan model of the Earth would be about the same height as the distance from Paris to Pythagoras' home on Sicily. Calvin also says, question your teachers. Now, since Calvin is teaching us here, I want to question him. What happens if we do scale it? So, this circle, you can check by the squares, has a radius that is 3 times the height of the building. As the building's height is twice the width, at the base, 6 times the width. So what happens if I put that building onto a larger earth? Having a larger earth, we could fit more buildings and maybe even a park. So here we are, same size building, count the squares, and now the planet has a radius 7 times the height of the building. Again, we have 3 90-degree angles, but the building doesn't look as wonky. Let's check the angle, and we find 95.88 degrees. Now, according to Calvin, this shouldn't happen as scaling doesn't matter. Remember, Calvin used no sizes in his video, so we could have used any size building on any size earth. We should get the same angle, and we don't. Now, builders say, measure twice, cut once. As a scientist, I want to make at least 3 measurements before I say I see a trend. So let's build another earth, like a full-on Magrathean. And this time, we'll make our ratio 20 times. Now we have 88.25 degrees. So I can see a trend. This is it. The larger the planet is compared with the size of the building, the closer this angle is to 90 degrees. I predict that if I draw a very big circle, this angle would be very, very close to 90. So what if I drew a very big circle? Well, I tried and I noticed something. I noticed that I lost the edge of the circle on the screen somewhere, so I tried again. And here is a circle. I got my program to tell me how large it was, and on my screen it is 1236 pixels wide. At this point, I drew a larger circle and also decided I liked the font. Now this larger circle hits both sides of the graph paper. I wanted to show you that it's still a circle by showing you it curves back on itself, just to disprove the non-circle conspirators out there. So I didn't show only half of it just by moving the centre of the circle down. But in the third larger circle, I intersected the part where the circumference hits the side edges of the paper with the bottom edge of the paper. Now watch. This larger circle intersects at the same place, but since it has a larger radius, the curve is less pronounced. This leads me to see another trend. That is, the larger the circle, the less pronounced the curve. So I predict that if I draw a large enough circle, you won't actually see the curve. If the section of the circle we are looking at is small in comparison to the circle. So, for this next curve, I tried to draw a circle the size of the Earth, but failed due to computer memory issues. So I scaled everything down. And I used the average radius of the Earth from Wikipedia. Again, I am staying agnostic on whether Earth is flat or not, but I can prove that Wikipedia exists. So I'm using their figure for a possibly existing radius of a spheroid Earth. It is 6,371 kilometers, which I've converted to meters. I've also chosen a height of a building that is a bit smaller, a bit more realistic than Calvin's model looked like. It's now 30 meters high and a width of 15 meters. Again, the building remains on graph paper, the same size, just look at the squares. The radius to height ratio is now over 200,000 times. The radius of the circle is over 2 kilometers in real life based on my monitor. My monitor would have to stretch from my cave another 5 kilometers to fit all this in. To walk around circumference, it would be at least 12 kilometers. I'm sure you can agree, Calvin, that if you were to walk a loop of 12 kilometers, you wouldn't notice a curve in what is half a stride the size of my monitor. You'd have to adjust your line every step. So again, 3 right angles, 3 exact 90-degree angles. And what do we get? Well, it looks pretty much like 90 to me. You can't measure, with the resolution of this monitor, the difference from 90. So I went in and worked it out with a little bit of GCSE maths. 89.9998651 degrees. That is 1.5 tenths of a thousandth of a degree away from a right angle. And just a quick word about significant figures. If I stuck with 4 significant figures, as I had done with other figures, it would just be 90.00. So I have chosen to use 4 significant figures away from 90 degrees. It does not change the angle, it just explains why it looks like I've moved from 4 significant figures. So, I have shown 2 things. The first is that the larger the radius of the circle, the less pronounced the curve is. The second is the larger the circle, the globe, is compared with the building, the nearer the angle gets to 90. I have also disproven Calvin twice, in that scaling does not matter. It does. And there is a specific angle. There isn't. Anyway, back to this. Calvin is right. On a curved earth, it will not give you exactly 90 degrees. But here's my conjecture. You cannot measure the difference between this angle and a right angle.
Firstly, there is no way that any instrument in the real world measures exactly. And the materials will be shaped exactly. No matter how accurate your cut is, your cement, your angle, your brick, there will be some things that are off the mark. Nothing is 100% accurate. And all we need is a couple of parts in 1,000 to be off. A plumb ball, a plumb line, a weight on a string will be affected by friction on the string, by vibration from traffic or other workmen working in the building. On this scale, local gravitational effects, again, if you're happy to use laser sights based on quantum mechanics, you're going to have to accept that gravity exists. I'm sorry, science is not the Bible. You can't choose bits of it to accept just because they suit your life better. These effects may be tiny, but tiny is all we need. Spirit and water levels, viscosity in the liquid will mean these tiny angles away from the horizontal, they may well read as horizontal. Maybe. Over time, the bubble will rise to the top, but that will take a long time, even compared to building project overruns. Laser levels. Well, a brief look online said that a good level is accurate to 2 millimeters over 150 meters. This is still not actually able to tell the difference between our value and a mathematical right angle. The angle of uncertainty at a laser level is still 5 times too large for our angle. And that an angle at 2 millimeters over 500 meter range is really, really small. Most builders, even you, Calvin, I'm pleased to have your 150 meter building, I assume you build them, building over 2 millimeters out. We can agree, it's really accurate. So what does this mean? And it means that, well, Calvin is right, that on a globe-shaped Earth, and all other angles being 90 degrees exactly, that angle, fourth angle, will not be 90. However, Calvin is wrong, that it will be a certain angle. Calvin, you are wrong, the scaling doesn't matter. We have shown that when you punch in the numbers or do a really accurate scale drawing, it becomes impossible to tell the difference between this one angle and a right angle. Are building on a ball-shaped Earth. So, Calvin, shows your thought experiment, your explanation does not disprove the globe-shaped Earth. We have to accept it is not only impossible to get 4 exact, spot-on 90-degree angles, it's impossible to measure them spot-on to a precision and level of accuracy where we can tell the difference. So having 4 90-degree angles to acceptable level of accuracy in a building is entirely possible on the globe Earth. So Calvin, I want my money. But just in case the publicity from Simon Dan's video, or maybe mine, has led to less commissions for you, I will offer you your money back. If you can find and demonstrate a piece of equipment in a standard builder's toolkit that can measure an angle to the correct precision and correct accuracy to really show the difference between this angle and the right angle. You can keep your 10 grand. Now, if you want more episodes like this or just on other things as well, subscribe, like, share, tell your friends about it, comment below on whether you think I satisfied Calvin's demands. I think I did. Comment below. And if you'd like to see me actually not have to produce this on a phone in a back room, then please, 10 grand or sponsor me. Simon Dan gets sponsor videos anyway. I do not sponsor video anyway. I do not. I'm just starting out. But here's a small tip if you want to start doing this. Don't use a Nikon D550 camera. It's a brilliant camera for photography, but the autofocus on it sucks. There's a small tip from me. Anyway, I hope to see you for another video very shortly. So, wish you well, until the next time.